thought I'd do a nice little stream or so, or do some nice little recording. Because, well, I kind of left off Sunday, and I was like, man, I really didn't like that day. It just did not work out. So I took some time out after that, and I got my brain working on it, and I was like, well, I didn't like all the calculations we were doing with quaternions, and it wasn't just right, it didn't look right, it just didn't even feel right. So, what I did is I started to think about what the actual problem is. The problem is I wanted to calculate my head position at an exact direction. Well, to do that, I really can't do it unless I do this complicated math, and it just didn't work out. Then I had a whole bunch of values up here, which, some of them are kind of up here now, and I had two quaternions, and then I had two vector 3s, and a whole bunch of other stuff, and I'm like, man, there's got to be a better way. Well, congratulations, I finally said the heck with it, and I found a different way. So, you're going to see a few things in here that you're not so probably familiar with, because I started testing and everything else, and I started to integrate the firing into there so we can get turrets that shoot bullets and stuff, but there's a limitation to it. Anytime you instantiate something in a large amount of objects, plus in these tower games, there's usually a lot of enemies. So I started thinking out inside the box, and I'm like, large amount of enemies, so my turrets can't be pulling a whole bunch of memory. Like, I'm talking like a whole bunch. Like a bunch of member variables at runtime, and a whole bunch. It just astonished me on how many things could go wrong with that I started thinking about it. So, I was like, time to do a fresh start. This add component right here, add component menu, and then there's a string. This right here, because I've got multiple things in my folder from an FPS kit, a war gaming, and a tower game, which we're on, I need to be able to centralize my scripts in a nice drop down, I think. And I made this drop down right here. Yeah, let's just point at the screen. That really helps. Oh yeah. Okay. Goofball me. Okay. So we made a tower kit, and then towers, and we have two different towers. One is a single point where one will only move at a single pivot. Okay. Single, and it's a cannon, that's cool. And then I got 2-point cannon, okay? And the difference between them is how many parts need to move, okay? If you have one that goes left and right, the top part of the head has to follow. You see what I'm saying? And that's what we was having problems with, because, I want the parent to be like, how you move your body, your legs move the whole rest of your body, right? Left, right, or whatever, you just move your leg over. Well, it didn't make sense for my tower to have to turn a little bit on the top, the head part and stuff, so I was like, oh man, this doesn't even work, this doesn't look good. So when I started thinking, I was like, well, we got this update, okay? We got if target, and I've got this targeting, which I changed the array base. I've got a lot of member variables because they're going to be used for all my turns. I'm pretty sure it's going to be all my turns. Now you'll see a target one. That's legit. Every turn, whether it's healing, whether it's blowing something up, or shooting, or anything, they're all going to have targets. So yeah, that's legit. Head, a single head part, yeah, maybe, possibly. But I still will need some form of place to make them shoot out or so. I mean, yeah, that's legit, I guess. You know, because whether I'm instantiating like some huge like particles and they're hitting like the rest of my guys throughout and healing them, yeah, it could come from there. I could see that. And then we got this float speed. Well, if you remember Sunday's live stream, the speed is how fast it lerps and turns and stuff. Yeah, that seems legit for all our towers for now. And then we got this head helper. This is new, okay? Now, don't pay attention to all this stuff, because that stuff isn't even integrated into it yet. Okay? This is our first save logic. Well, you already know all about this. This is nothing. This doesn't even get saved in our save logic, so technically it shouldn't be even in this part. But it shouldn't even be in any part. Firing, physics, behavior, no. It should actually have its own little tagging to explain what it is. This UI upgrades for later in development, not intro in project yet. But we will need to have access to some form of, you know, like something. And, you know, for our saving behavior, we need a string, which is this class right here, which would be string and then something else. What else is it? Tower classes. Oh, ooh. It's a string and a vector. Okay, yeah. Because we don't care about the rotation yet. But we might later. But it would be very easy to integrate anything we want into the save tower right here. So, very useful information. Now, to the cannon. Okay? Now, we have this right here. Target check. Target check is a vector. Okay? Which we have to calculate the target position minus our position. Okay? Actually, I don't even know why we have this. I know it's for a reason. Oh, and we also have a range that we're calculating. That is going to be useful because who wants to shoot something beyond a range? You know, that's kind of dumb, right? So let's not do that. And then if it's greater than range, we put the target. If it's not null, we enable the collider and put it null. Now the reason why I might disable and enable the collider at runtime, that I don't know how the physics engine is going to like that for scripting wise. Because here's the thing, on collision enter and exit, we'll be setting that. So, and this update will run when it has a target. But the thing about it is, the physics engine, I don't want it to keep calling it every single time enemies are coming in. Because that sounds like an operation that could be very performant heavy if you got a large amount of enemies. So it might be better performant to just disable the collider when we don't have a target. Because we're going to have a lot of targets, okay? And we're going to want some way of, you know, choosing targets, but not only that, but telling the physics engine to go pretty much, you know, quit working. Now, we could do a for loop and loop between all the enemies, but if you think about it, in order to spawn in an enemy, then I'd have to put it in a list. And then have every single turn in the game loop through that list. That sounds performant heavy to me. That would be a very heavy operation. I mean, don't get me wrong. The searching through a list would be very, very fast. Lists are fast, okay? But comparing the distance and everything to it, that sounds like a heavy operation. You know, for, let's say you have 30 turns in the game, 30 every single frame. I don't know how that would actually run, honestly. Especially if you're doing this for mobile. Okay, if you're porting this over to the phone, there is no reason this kit as it sits would not work for the phone. Okay, and later on, if I can get my one buddy that we're working on an FPS tutorial to make sprites for a turret, maybe we'll release this for the mobile version. You know, make turrets that are 2D and then make a 3D version of the game, like kind of both, because this code will work in 3D or 2D space. There's no reason why it won't. None. Because 2D space doesn't care about the Z factor. It's Z factor. Which in this, it doesn't even matter, because what we're doing when it comes to the targeting, you see this function right here, this helper, head helper, then look at. This, every single frame will directly look at the object. It will look at it like right then. Bam, 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 bam. Over and over and over and over again. Okay? Let's embiggen this. So, okay, look at. We'll do exactly that. It will look at the target. And it will look exactly in the center of our cube that we've got right now. And it will... no calculation problems. Okay? All those quaternions and stuff that we were doing before, it doesn't even care. Okay? You see where I'm getting at this now? No math. Absolutely no math. And this look at is directly inside of the Unity documentation. It's very easy. There's a tutorial about using look at. But it has no smoothing. Like if you wanted to turn the turret, like let's say you want to take the turret and you just want to... Why is my thing always in 2D? Every time I go to do something. Like right here. Like you want to take your turret. And I know this isn't exactly the most efficient, easiest way to look at it. Why does it zoom in really quickly? I'm about to just make my model like really huge. Let's just do that. Okay. Because this is getting ridiculous trying to zoom in. Okay. So what the look at target will do is, instead of turning real slow or something like that, or no, let's like this, turning real slow like this or something, it will just go, hey, I see something, wing, and look directly at it, wing, look directly at it, no smoothing whatsoever. It'll be like instant, which is not what we want. But and here's the great thing about it, since it does that, we can take that and put a helper on the head part. The head part. It'll be a child of the head. The thing we want to turn on a smooth rate, frame rate dependent, right? We'll use that game object, the empty that has nothing, absolutely nothing on it. And we will take the, which will give us a look at target, which then gives us the perfect rotation. Now you know what I'm getting at. So we take that perfect rotation, we go head transform.rotation, which is the game object and we go quaternion.slurp the head. Come on. The head transform.rotation, and then we take, guess what? The helper, the game object. Why do you do that? Why are you? Why? The head transform.rotation. Okay, so that perfectly look. Oh, I'm not even gonna highlight it. Nope. This stuff right here. This. The head transform.rotation is the look at target. The game object that we have, the little helper, it's in the perfect rotation already because the look at is doing its job. So we tell the head transform, hey, I want you to basically lerp to this position at a speed times by time.delta time, which makes it frame rate dependent, so you get a nice smooth movement. And guess what? That is the whole targeting right there. Everything on a single pivot. So the head transform is the only thing that moves left, right, up, down. You got the perfect rotation with absolutely no quaternions, no math, no nothing. Perfect. Okay? Which is nice. That's what we want, right? I mean, that's what I want. That's what I spent, like, what, 8 hours on stream trying to figure out a good quaternion math to give you guys for making it, and ends up being sucky anyway. When I could have just done this one line of code that runs severely, like, I'm talking very, very quickly. Okay? So there's no generated overhead pretty much for this. I mean, it's super fast. I mean, we've got one member variable for speed. Woo! And the head helper, which is an empty transform, which is nothing, and our head transform. You know, I mean, the other method that we had like, what, new vector 3s like twice and other memory stuff. This is like the most efficient way that I could possibly find to do this. It's great. So yeah, that's my achievement out of the whole day of thinking. I'm like, why didn't I just do this before? Wow, my life is so much easier now. Now we have this firing method, which I don't really have integrated yet because, you know, I haven't decided on how I'm going to do the firing stuff. Which this turrets, I suspect, are going to have firing for every turret. That's why I put it in the base script as a virtual. Okay, because I know we're going to save on every turret we have. There's no doubt in my mind for that. There's none. We have to save it for some type of save system. So, you know, that's legit for me. And then gizmos, yeah, I could see us always have a gizmo, and it's going to be on the head transform. So I just made that a permanent variable across the board for every one of our inherited classes that inherits from base class. So this script is pretty simple. You know, I mean, the firing, this is just an angle, a calculated angle from the head transform dot forward and the target check. Now the target check, where am I doing that? Target check. Target check equals, okay, so we've got some math going on there, which, you know, is what it is. That's the thing I was wondering. So let's take a quick look at our tower base. Okay, we've got upgrade, that's not new, the target transform, head, those two transforms, which, you know, seems legit. Speed, the head helper, well, I look for the head thing to be there, you know, pretty substantially. And the fire time, I have this public, but I have hide in inspector. And the reason why I do this is because when we're using inheritance, member variables that are in the base class have to be public so that you can overwrite them in other classes and things. They have to be public. They can't be private and stuff. Actually, matter of fact, here's what I'll do. To show you guys what happens, I will put this let's go private. And we will save, and Unity will complain and whine. Non-existent, non-accessible. Okay. Asset towergame.scripts.towerbase warning. The private field towerbase.firetype is assigned, but it's never given a value. Huh. Private. You can put it a private. Wait, what? Fire time? Oh, yes, that's right. Fire time. Yeah, it starts doing those whining and stuff. But it doesn't, like, wreck it. Ooh, I do know you can't do it protected, that's for sure. Protected. Yeah. You can't just have it protected. Because it's an inheritance, it will definitely give you an error on that one. What? Really? Well, that's it. Oh, well, that kind of seems legit. Okay, so it's going to call me a liar. Okay, whatever. I don't care. Fire time's going to get used across the board for it anyway. Because, well, actually, yeah, it is. Because here's the thing. Like we did in our FPS shooter game, okay? We need a fire time, alright? Because here's what happens. When we shoot, we need to go and put a rate on it. But it's got to be time.delta time based. So, well, time.time, or whatnot, which, can be manipulated or whatever. But we need some form of way to make our towers go, hey, we add fire time into our next time. So basically we go, if fire time is less than or equal to time.time, do this. Basically it's like adding it and just going, hey, if it's greater than this, we can shoot. If it's less, then we can't. It's basically like a bool. No big deal. But I don't want like some coroutine that just doesn't work for us. So we'll have this, but would I want it to do the targeting function for that? Yeah, no. Actually, yeah, we probably always will. Targeting will run, but this distance check and stuff like that won't. Yeah, we'll probably put the firing time right here. Firing goes here. Firing goes here. That's what we'll do. Because on the last stream, I didn't want to leave you guys in a spot where, hey, this doesn't make sense, because my code kind of sucked. So, making me in that squeaky chair, me making a better code for you guys for a single turn like that would be more of my taste, because if I give you code that don't work, then that just sucks. because I feel bad. And it's kind of a jerk mood anyway. But so it does work now, and it works really well. You should not have a problem with that single turn again. Not that way anyway. But on our 2-point turn, okay, 2-point. This is a one that has more variables and stuff. This actually has more functionality and things in it. Okay, so on our 2-point turn, we do have this variable in our 2-point this script, the actual tower script itself, because this is unique to this turn. Okay, so we do not want this in our base class at all, or even in our canon class, because a body transform is only used to do a 2-pivot system. Like if you want one piece of it to go up and down, and then the other piece to go left and right, well, guess what? You need a 2-point system, which gets more complex, and that's what I wanted in the beginning of it, but it doesn't really work the way I like for it to. So I came up with this. Now, don't get scared of this code and it looks all complicated and everything else. It really is not. If you understood the last script, this script will be very, very easy for you. Okay? And I'm going to go through it as slowly as possible so you understand what's going on here. Okay? It's a public targeting, and we're putting in my target. Now, the head, it does its look at, which is a helper. Okay? It will directly look at this target right here, which is the one we want. And then we're basically telling, hey, helper transform your angles. The actual angle that it's going in currently right now, we are forcing this transform to stay in a certain position. Now, you're like, why don't we just do a single one? Well, in a single frame, I want this to run right here. This X, I want it to keep its X position. But in the head part, we don't want it to do the Y functionality, which could be different for your model. Who knows? But I want my body helper transform to follow this left and right position. This is left and right on. Okay? So, yeah, it's going to do exactly that. It's going to follow it perfectly. Okay? And then this last one, I just put the 0. Which you might have to manipulate these according to your model. Okay? It all depends on where you put the origins and stuff. Okay? And if you understood the last one, you got your head transform. And this is where we're lerping the head transform rotation. Okay? The rotation at a speed times by time dot delta time. Okay? Simple as cake, right? I mean, it's just like the other turn, right? Except we're forcing angles to stay in a certain position using this function right here. Yes, it sucks that we're creating a new vector 3 right here, but it's the only way that I found to do it, to do the calculations and be efficient enough for a good game. And it's happening every frame that it's moving, but it's not doing it every single frame, only when we have a target. Okay, now we're slurping it, yes. Now this body transform, okay, this helper is looking directly at the transform. Okay, that gives us our perfect angle for the body transform. And on this one, the body transform helper, we're forcing a transform to stay at a certain position. Okay, which is 0 for the X. Now the Y, we want it, oh man, that's annoying. We want it to keep its transform Euler angles. This is the world degrees of the Y. I want it to stay that way. Okay? And then the next one is 0. Now, based on your models, this could be a little different. This could be tweaking a little. So, like I said, you'll have to manipulate these a little maybe to get it to force the certain angle that it goes. But that's all we're doing with this. Okay? And this is the body helper. So, the X, the up and down, and left and right. The only thing that this is going to be allowed is left or right. That's it. Left or right on your model. That's it. If it tries to go up and down or any other type of direction, it will not allow it. Now we take the rotation that we've had, and we do a quaternion slurp, basically lerping the rotation, okay, to the body transform dot rotation. So after we forced it to stay in a certain angle, we'll then lerp that way. And it's based on speed and times by delta time. So we make it frame dependent. And that's the targeting on a 2-point system. Very efficient. I mean, look at this. What, 2 vector 3s that we're making right there? That's it? And look. This stuff right here. That's it. On the other thing, we had 2 vector 3s, 2 quaternions for one and the other. It was a mess. So yeah, I put a lot of thought into a new targeting system for you guys. And we have our save. Okay, very simple. Already discussed. Now we have our gizmos. Now we're overriding the gizmos, but we are calling the base. So, we get all the base functionality for the head because we're inherited from it. And we just go, hey, guess what? Wait a minute. We don't need this line of code. Do we? No, I don't want to start. Gosh dang it. Stop. Stop. Okay. Blah. I don't care. We probably don't need this. This is just so that we can debug and stuff in the editor and things. See what's going on. But we don't need it. So that is our tutorial right now on a tower base class. And wait, what? I don't know why I was doing that. I'll have to look. But yeah, this is a single. This is our saving class, and combined with our tower class right here, and that's the 2-point system. That 2-point system right here, this right here, very efficient for mobile. I mean, you're pulling hardly anything, and yeah, that's if you want a 2-point system. All your turns, if you model them, you may only have one pivot thing that you need to move around. So this cannon right here, you could literally do this right here. Okay, more cannons. Okay, and this doesn't pull nearly as much memory as you might believe for that. So that's just something to think. If you find this to be too much memory for you, well, make this tower class cheaper so they'll use more cannons. But yeah, I think I'm going to code the firing system probably later, maybe after I get some food and stuff. But I wanted to record this video so that basically record it and stream it and everything, so that you guys could see it up on the archives of Twitch and plus YouTube later. In case you watch Sunday stream and you're like disappointed, well, trust me, you're not going to be disappointed with this script. If you copied everything from here, trust me, this will work fine in mobile. It will work perfect. I have no doubt in my mind. Now, the next thing that I think we should hit, as in our tower classes and stuff, is possibly object pooling, so we can instantiate large amounts of objects without pulling tons and tons of memory. And I think every bullet that I have for the turrets is going to be roughly the same, or maybe we'll make two classes of the object puller, where one object puller does nothing but for cannons, like cannonballs and stuff like that, or vice versa. But we seriously need we need object pooling, that's for sure, because if we don't do that, we're going to have tons and tons of instantiate and destroys, and that will hit our garbage collector really badly. Really badly. And two, when we get into, if I decide that I'm going to do it, I don't know yet. If we decide to make a drag code where you can drag multiple turrets, like a big old line of them in there, possibly, then we will definitely need a object pooling class. So that way, when you drag back or you drag forward, we won't be destroying so many objects and stuff. But I haven't decided on the architect of an object puller yet, so you know, it could be a little while for that one, or it might be tomorrow. Never know. Or we might decide to go with the most performant way, and the most performant way is to do particles. Particles are cheap and they look great. All that smoke and you see when you play like Call of Duty and stuff, that's not meshes or anything. No vertices whatsoever. It's all particles. And you can do some sick stuff with particle effects. Like the smoke coming off a cannon when it's sitting there shooting like a whole bunch of bullets, or, you know, let's say we want to do firing for a machine gun or Gatling gun or something. Because the way we design this is it can work with a 3D game or a 2D. So this as it sits, I have no problem sitting there telling you straight up it'll work on 2D or 3D. I have more than enough confidence to say that it will work on both. Even with the old tutorials versus this one, the only limitation you're going to find from the old versus new is simple. It will be the model, your rendering graphic pipeline. That's it. Because my old system, I believe, oh no, my old system, I checked, it had no firing code whatsoever in there. I mean, my really old one, I think, did. Yeah, but I don't think I actually told you guys how I did it. So, but placements and everything, yeah, we might go through that again, you know, because we can do some more stuff with that. We can definitely do some more stuff with that. But yeah, I'm gonna end the stream on this fact right here. But you know, like anything, if you want to follow for Twitch, you know, go to Wardon 508 Yeah, at Twitch. That's my Twitch channel, and YouTube. Just I think it's linked in Twitch, but YouTube. Just search up Wardon 508, and you'll see a picture, probably the same picture that you see on Twitch. But yeah, that's uh, that's definitely it, and you know, like, hit, subscribe, whatever this Twitch does. Well, Twitch follows, yeah, and so does some of the other things. But take care, guys, and have a nice day.